All right, let's jump right in. We're going to talk about something super interesting today, a new kind of AI that actually learns from you just by having a conversation. And it all starts with a question that I'm sure has driven you crazy at some point.
I mean, seriously, haven't you felt this? You're talking to your AI assistant, you correct it, you try saying your question a different way to get a better answer, and then what happens? The very next day, it makes the exact same mistake. It's like talking to a brick wall, right? It just doesn't seem to get any smarter.
Well, the researchers behind this paper have a great name for this problem. They call it wasted wisdom. And it's such a perfect description because every single time we talk to an AI, we're handing it this gold mine of data, and it's just, tossing it in the trash.
Just think about it for a second. Every time you fix what your AI says or you rephrase a question, you're giving it feedback. That feedback is basically a free lesson, but it usually just disappears. Poof, gone. And that lost feedback has two super valuable parts. The first is what we can call evaluative. That's the simple good job or bad job, a thumbs up or thumbs down. The second part is directive. That's your correction, the part that actually shows the AI how to be better next time. And right now, both of those signals are just being wasted.
So, that brings us to the core idea of this whole thing. What if we could stop all that waste? What if we could actually capture all those lost signals and use them? Imagine an AI that learns and gets better in real time with every single conversation you have.
And that's exactly what these researchers built. It's called OpenClaw-RL. It's a new framework designed to do one thing: stop wasting all that wisdom. It's built to grab that feedback that used to just disappear and use it to constantly make the AI smarter. And the whole thing is based on one really simple but kind of brilliant idea.
That idea is something the paper calls the next state signal. Now, that sounds technical, but it's super simple. It's just whatever happens next. After the AI says something, what do? Do you reply? Does a program give an error? Does a tool spit out some data? All of that stuff is the next state signal. It's a free, constant stream of feedback that's been hiding in plain sight this whole time.
So here's the magic. This creates a non-stop learning loop. Look, you ask a question, the AI answers. Your reply, whatever it is, becomes the feedback. And boom, the system learns from it right then and there. It's this simple, elegant cycle that just happens in the background while you're using it. No extra work needed.
Okay, so the system is grabbing all this feedback, but here's where it gets really clever. OpenClaw-RL doesn't just see it as one big blob of information. Nope, it's smart enough to pull out two totally different kinds of feedback from that one signal. The easiest way to get this is to imagine you're training a new intern. You're not just going to walk by and say, good job or bad job, right? Of course not. You'd also tell them why it was good or how to fix it for next time. Well, this AI learns in pretty much the same way. So here are those two types, side by side. On one hand, you've got evaluative feedback. Think of this as a simple score, a thumbs up or a thumbs down. It just answers the question, was the response good or bad? But then, on the other hand, you have directive feedback. This is the good stuff. This is the specific advice. It answers, okay, how exactly should the response have been different? One tells you if you're right, the other tells you how to get it right. And these images really nail the difference, don't they? You've got the simple check mark, that's your evaluative feedback. A quick, yep, that's good, or nope, that's bad. But then you have the speech bubble. That's the directive feedback. That's the actual conversation, the advice, the details on how to improve. One is a grade, the other is the teacher's notes in the margin.
All right, we're going to get just a tiny bit technical for a second, but stick with me. The system uses a different machine learning trick for each type of feedback. For that simple good/bad score, the evaluative signal, it uses something called binary RL. Think of it as a simple reward system. But for the detailed advice, the directive signal, it uses a more complex method called Hindsight-Guided OPD. Now, you don't need to memorize those names. The only thing you need to know is that it uses the right tool for the right job, a simple tool for simple feedback and a more advanced tool for detailed feedback.
Okay, that all sounds great in theory, but the big question is, does it actually work? Well, let's look at the proof. The researchers ran a really cool simulation to see if this could create a genuinely personalized AI assistant. So here's the scenario they created. It's pretty clever. You have an AI assistant helping a student with their homework, but here's the twist. The student doesn't want to get caught using an AI, so the answers can't sound like they came from a generic chatbot. The AI's mission is to learn the student's unique, personal writing style.
So, at the start, before any learning, the AI does what you'd expect. The answer is technically correct, but it's super robotic and generic. You know the sound. It's helpful, sure, but it just screams, I was written by an AI. Absolutely zero personalization.
But then, check this out. After just a handful of conversations, where the simulated student just kind of rephrased things to sound more like them, the AI totally adapts. It picks up on the user's preferred style, their tone, their formatting. It's the same correct information, but now it's delivered in a way that sounds way more personal, way more human. And the numbers back this up in a huge way. They measured how well the AI copied the student's style. The starting model, it scored a measly 0.17. But the updated model, after only 8 interactions, we're talking just a few back and forths, jumped all the way up to 0.76. That is a gigantic leap in performance. It learned, and it learned fast.
Now, making your personal assistant sound more like you is awesome, don't get me wrong. But this technology is way bigger than just that. The core idea here is incredibly powerful and can be used for so much more.
Because remember that next state signal? It's universal. It exists everywhere. So you can use this same exact learning method to train AIs to do all sorts of complex stuff on a computer. We're talking about learning how to use a command line, how to operate software, even helping with coding and using other tools. Basically, it can learn to do almost any digital task, all from that same automatic feedback.
So let's take a step back and look at the big picture here. What does all of this really mean for the future of how we're all going to interact with AI?
The key takeaway, the most important thing to remember is this. The future of AI is adaptive. We are finally moving away from these static tools that never change. This research lights up a path to a future where our digital assistants actually evolve with us. They won't just be tools we use. They'll be partners that learn and grow alongside us, just from our everyday conversations.
And that leaves us with one final, pretty mind-bending thought. Once this kind of tech is in everything, our AI assistants are going to become mirrors, reflecting how we interact with them. So let me ask you, if your AI could learn from every single one of your interactions, what's the very first thing you'd teach it?